I'd like to welcome you to today's TechNet webcast. This is Advanced SQL Server Integration Services. I'm pleased to introduce today's presenter. We have Donald Farmer, and Donald is a Group Program Manager with Microsoft. So Donald, you've got the floor.
Hi, thanks very much. Yep, I'm Donald Farmer. I'm the GPM for SQL Server Integration Services. And we're going to be talking today about some advanced features of SQL Server Integration Services. In particular, some features that you may not have come across or you may not know how to use. And we're responding very much to requests that we've had from users about information in this area. So what are we going to cover today? Well, 3 advanced techniques. The first thing is web services techniques for SQL Server Integration Services. We get a lot of requests about how people can use integration services with the web service environment. People nowadays are exposing a lot more data and a lot more of their business processes through web services. And so it's natural to want to integrate them with the data integration process. We're also going to be talking about text mining techniques. Much of the data that you'll find in their businesses is unstructured, and we'll talk a bit more about that later. And the unstructured data typically needs the ability to get into that free text data and pull out sort of key terms and important terms from that, and build warehouses or build reference tables and so on. So we'll be showing you how to use text mining to achieve some of those goals. And then finally, we're going to be talking about a really interesting area for me, which is the ability to use data mining within integration services. And we think this is one of the most compelling features, a bit of a sleeper feature in integration services, something that most people will see there as a checkbox in the tool set and wonder what the real business cases are for using it. And we hope to talk a bit more about that and reveal some of the really interesting cases that you can put data mining to use for. So what do you need to know for this presentation? Well, it's an advanced session, but actually I want to emphasize that a basic knowledge of how to build integration services data flows will really be all that you need. I hope that the demos that we show will show you some additional techniques that will be useful. So let's start with some basic knowledge. One of the examples does use quite extensive VB.NET script, but that's okay. I think you'll find that's fairly easy to walk through. So the first item we're going to cover in the agenda is the item of web services. Now, those of you who've used integration services already will have noticed that there's a web service task in integration services. And a task is part of our control flow environment. It's a unit of work that succeeds or fails and does a discrete operation. And the web service task in integration services is really for simple web services access. It simply goes to a web service and passes some parameters to that web service, to the web service method, and then returns data from that web service, which will be in the form of an XML document that comes back from the web service. And you can save that XML out to file, or you can put the XML into a variable where it can be used later in the package. But it really is for simple web service access in that very simple invoke a method, get some data back environment as part of our control flow. We only really support the simplest of schemas for web service description language. And one of the reasons for that is simply that the complexities of how you can access web service are really remarkably complex. There's a great deal of subtlety and complexity in being able to connect to web services. And in order to create a simple task that can just go and do the basics, we did cut down on the scenarios that we support. In the RTM version of SQL Server, we did not support the ability to set parameters dynamically, and that meant that really the web service could just make the same call all the time. And for many scenarios, that was okay because it was being used in a control flow environment where it was checking that a service was available or getting a standardized message back. But we did get a lot of requests for dynamic parameters, and we've done some work in SP1 to make that possible. So you will see that coming in SP1. How would you use web services in a scenario where you wanted to, for example, use the web service as a data source? It's kind of possible to do that using the web service task. You can save the web service result set back as XML, either in a variable or to a file, and then the XML source adapter in the data flow task can pick up that XML and process it into the data flow task. But to be honest, we've had a lot of feedback from customers that they'd like to be able to use not only true web service sources, in other words, to have the full functionality of the web service wrapped inside the data flow task, but also that they want to be able, of course, to handle dynamic parameters and a lot of the complex web services that the task does not support. There's a smaller demand for web services destinations, and a web services destination is something that is also supported in the data flow now if you do this using the script component. But that's certainly a smaller demand. Finally, there's the demand for web services as a transformation object, and that certainly is something that we're very interested in. The idea here being that as rows are passing through your data flow, you could call out to a web service and execute a web method on each row that passes, using parameters based on each row that passes, and then therefore use the web service as a transformation object. Now, these latter scenarios, using web services as a source, using web services as a destination, and using web services as a transformation, these can all be achieved in the data flow using the script component. And that's what we're going to be primarily focusing on in this session, is how to use the web service as a script component. Now, the web service I'm going to use as a sample is one of the web services from Amazon, who have a set of commercial web services that you can use in demo mode as well. The web service that we're going to be using is pretty straightforward. But I can only use a small set of data. I can't go and download all the books on Amazon or all the products on Amazon. So we're going to be looking at like 10 products at a time, but it's enough to give you a flavor of what's available. So let's look first of all at what we have to do to prepare our web service for the script component. Well, as in any case where you're programming a web service client, the first thing to do is to download the WSDL file, the WSDL file, the web service description language file. And when you get that web service description language file from the web service, the next step is in fact to generate a proxy for this, generate a proxy class. Now, the web service description language for the Amazon web service that we're going to be talking to is in fact on the internet, and rather than downloading it directly, I'm simply going to download it from this location, and we'll download it from there. We'll invoke WSDL.exe, and the output will be a C# class. Now, the C# class is the default that WSDL.exe creates, so we're just using a default setting there. This will generate a proxy class that can be used. Our next step is in fact to compile the proxy class into an assembly. Now, the integration services script component is a VB.NET script component, but it's not restricted to calling assemblies written in VB.NET. You can call any .NET assembly. So we're going to compile our proxy into an assembly. And to do that, there's a few things that you need to have available. Now, this isn't a presentation on how to build .NET assemblies or any of those things. And I suggest that you look at the .NET documentation, the .NET Framework documentation, or the VB.NET documentation on how to use web services for more detail on this. But essentially what you're doing here is invoking the C# compiler. Now, the C# compiler comes with the .NET Framework, and you'll find it in your .NET Framework folder. I'm invoking the C# compiler here, and I'm giving it a target of a library, in other words, generate a DLL. The output should be this DLL, which wraps the Commerce Service proxy. And I need to provide a key file. Now, a key file for .NET is simply a security file that includes public key, and that's used to create what we call a strong named assembly. And it's going to generate it from this C# file, which of course is the C# file that we generated earlier when we created the proxy class here. So Having done that and created the proxy class and compiled it to an assembly, the next step is to compile it to an assembly to our framework folder. Now, your framework folder, in my case, looking at SQL Server 2005 RTM, is this folder here. Typically, you'll be compiling it to whatever is the most recent version of you'll be copying it to whatever is the most recent version of this folder. So these are the steps. Find your WSDL file, generate a proxy class, compile the proxy class to an assembly, and copy the assembly to your framework folder. There are some other ways to do this, but this is, to my mind, is the most straightforward way, and one of the ways that we find most effective and most reusable. So having done this, you're now ready to use the web service in our integration services project. Now, the way we're going to use the web service, as I said, is calling it from a script component. And you should know a little bit about how to use a script component already if you've been using integration services, because that's one of the most interesting components there. However, when we come to the demo, I will actually show the script component in a little bit more detail, so don't worry too much if you haven't seen it already. Now, once we've created our web service and we've opened our package and we've added a script component to it, the first step for us is to, in fact, add a reference to the assembly to our script project. In the demo, again, I'll show you how to do this. But essentially, you have to find a reference using the add reference dialog box. Having done that, you can now actually write script which calls methods in the assembly. And so you create an instance of the web service simply by creating a new web service instance, and you call the web service in the script as you need to. Now, in integration services scripts, there are several ways in which you can use script components. The script component can be used as a source. Now, when you create a script component as a source, it will automatically put in some stub code, if you like, a template of code for you. And the code that you're most interested in when you're writing a source component is the method create new output rows. Now, create new output rows, as the name suggests, is where the source component builds the rows that will be pushed down into the data flow. And so those rows will typically, in a web service source, be based on values that come back from your web service. So this is where you're going to do the majority of your heavy lifting code. If you were using the web service as a transformation, then you would be doing the work when you were processing rows in the script component. And if you were using work as a destination, you would write some special code to handle that. So in this case, we have added a reference from the web service straight into the script. Now, at this point, I think it's difficult to show all these things on slides and to step you through every step of the code. So what I'm going to do in this case now is show you a quick demonstration of how to use the web service. Now, the package I'm going to show you in this demonstration is a somewhat complex package in that it also features some of the features we're going to be using later on, such as text mining. But at this point, I'm going to concentrate on the web service example. And so at the end of this presentation, you'll actually have a complete package which does both web service access and text mining together and shows a kind of really interesting business scenario built around that. So at this point, I'm going to pass over to Visual Studio, the Visual Studio environment, where I'm building my web service package. Now, before we get onto the web service package itself, let's look at a couple of things that we had to do in order to get there. The first thing I had to do was, in fact, to get the WSDL file. And you can see here that in this batch file, I have the same command as we had earlier to invoke WSDL, to call down this WSDL file from the Amazon.com site to get the web service definition, and from that to generate the C# class. The C# class is here. Now, this is one of the great things about integration services is that it's integrated directly into the Visual Studio environment. So I've actually got my C# class here. I can see it with full highlighting, and I get the full C# editor right inside my environment. Notice that I've added it here into the miscellaneous folder, so it's even inside the same project as my integration services, web services packages. That means, by the way, that I can do things like add all these to version control together. And that way I can ensure that the package and the classes and the batch files to compile the assemblies and so on all remain in sync as I'm passing through this. So this is the generated C# class. Typically you don't need to know about this. You can even go through this entire process without even opening the C# class in this case. Having generated the C# class, the next step is to compile this into an assembly. Again, I have another batch file here. It calls the C# compiler. Notice, by the way, that what I'm doing here, in fact, is calling the C# compiler from, I'm putting an explicit path to that folder to ensure that I'm picking up the correct version of the C# compiler for the .NET framework that I'm going to be using. The output from the C# compiler will be a library, because I want to generate an assembly that I can call from other processes. And the name of the output will be this assembly here. I'm going to pass it out to that folder. And then I'm also passing in, very importantly, my key file to create a strong named assembly. And this is my key file here. If you need to generate a key file, you can use the utility sn.exe, which generates strong named keys. And then finally, here is the C# class that I'm going to pass in. So having done that process, I will now have an assembly that I can add to my integration services project. Now, the package that I'm building here is quite simple. Let me first of all show you what I'm doing. I'm doing some preparation, and there's some interesting work going on here, which we'll look at later when we come to look at the text mining example. And so the overall package is somewhat more complex, but when I actually look at what I'm doing with the web service, it's really pretty straightforward. I have a script component. I can drag on a script component at any point simply from the script toolbox, when I add a data flow task. So I can drag on a script component from here. When I configure the script component, I have to double click on it, and the first step is you have a script transformation editor. Now, this web service that I'm going to be calling, it's going to give me back names of products. And the example that I'm using here is I'm a mountain bike company. If you're familiar with the AdventureWorks samples in SQL Server 2005, you'll understand that I'm probably working for AdventureWorks, for example. And I want to get the names of top-selling mountain bikes from the Amazon website. Amazon selling not only books, but many other things as well through its stores. So in order to get data back from the web service and into the data flow, I need to create some outputs. So here I declare the output columns I'm going to use. And it's quite straightforward to add an output column. You just say click Add Column here. And I add 4 columns, the title, which is a 2,000 character string, the manufacturer, which is a 255 character string, a review, which is the description of the item in Amazon, again, which is a 4,000 character Unicode string, and the URL, which is a 1,000 character string. So I add those columns explicitly. This is not done automatically. We don't look at the web service and say, this is what's being returned. You have to add these columns explicitly. The next step is to actually edit your script. You move to the Script tab and click Design Script. And when you do that, we'll actually open the Visual Studio for Application environment. The Visual Studio for Application environment is a full editing environment for Visual Basic .NET. And as I say, we provide the kind of basic stub component scripts that you can extend to include all your own functionality. Now, if you remember, the first step to using a web service in your Visual Basic .NET script within SQL Server Integration Services is to add a reference to that web service. Now, you can add a reference in several ways. I've actually already created this script, so the reference has already been added, and I can extend this and see the reference here. But the way I would do this typically is to click on Project and add reference, and I would find the components that I need to use, the assemblies I need to use. In this case, I find the AWSE, the Amazon Web Service that I wanted to add, and you'll see that it hasn't got a full version number because I just compiled it on the fly from that script. So AWSE Commerce Service. I would also need to add the system.webservices assembly to this in order to be able to use that in my components as well, in my script component as well. So I would select an assembly, I would press Add. I can do that here if I need to add the web services. Click Add, and that would add the reference to the references folder here in the Project Explorer. And there's other things you can do here once you have the references added. It's possible to go and look at the properties of this web service, for example, from here. So to the script itself. Most of the work in a script component is done in the script main class. And you'll see that what I have within script main, the first thing I do is to create an instance of the web service. So I create an instance of the web service, and for the Amazon Web Service, there's some other objects that it's useful for me to create instances of. Now, this will vary depending on the web service you're using, so this is not generic. But the Amazon Web Service uses search responses and search requests and search items, and I'm doing that. There's a collapsed region here, which includes my Amazon Web Service ID for connecting to the web service. I'm sure you'd all love it if I shared my ID and password and so on live on the web, but I'm not going to do that. So I've collapsed that into a region so you can't see it, but I use it later on. Now, remember if I said that we were creating a data source, and a data source is a component which creates output rows and delivers those rows to the rest of the data flow to consume. And so all the work I do here is, in fact, within this method, create new output rows. Now, you don't need to worry about coding this method up, the method call, because we add that by default, and we add these comments and so on when you choose to use a script component as a data source. For more information on the script component, there's a lot of support in books online, some great descriptions and some great samples of how to use the script component. So I'm not going into too much detail about that. I'm showing you the specific scenarios for using the web service. Now, a lot of the work here I'm doing is very specific to the Amazon Web Service. I'm setting up my responses and so on. Two things to look for, though, is that I'm actually searching for title, mountain bike, and I'm looking in a category, what they call a search index, sporting goods. So I'm looking for anything that has mountain bike in the title in the sporting goods category. This is where I pass in my ID that I hid earlier on. I create a search request object, and I invoke the search request object. Now, here's the interesting part down here, where I start to go through every object that is returned from the Amazon Web Service, and for each object that's returned, in other words, for each item in the response, I add a row to the buffer. So for each item, I'm going to push a row out of the data source. And then I simply set the values for those columns that we created in the editor, and I set the values to the appropriate items that were returned from the web service. Now, how do I set those? It's actually very straightforward. Because we have a full Visual Basic editing environment, IntelliSense actually helps me greatly here. I can say output 0 buffer, and just press dot, and you'll see that I actually get all the columns that I've said I wanted to use available, so I can actually use IntelliSense autocomplete to build this pretty straightforwardly. Notice that this is called output 0 buffer. If my output was called something else, then it would be called output name buffer. For example, if rather than calling it output 0, if I had called it my source output, then this would be called my source output buffer. I can find that fairly straightforwardly by invoking that here as well. So Having then created my rows, one for each item returned from the web service, I'm writing into the columns, and that's really all I need to do. At that point, I can return from the script, and the script component will have created its work. So let's close down the Visual Studio Editor here and say OK at this point. And I'm going to show you how to use this component. This component will go to the Amazon Web Service. And what I'd like to do is just show you the results that I get from that. So I'm going to right-click here and add Data Viewer. And at this point, we won't run the entire data flow because you'll see that it has some data mining components in it. You'll see that I can view the outputs here. I'm going to execute the web service package, and it's going to look for mountain bikes and sporting goods, remember? So let's do this, execute the package here. It'll open in debug mode. It will attach a data viewer for me. And once it's opened in debug mode and opened the data viewer, it will then start the execution of this data flow. Remember, there's some couple of other tasks happening immediately beforehand. And once it starts the execution of this data flow, the first thing it will need to do is invoke the script, go to the Amazon Web Service, and return some values. So at this point, it's just starting up the package. And we'll be running through the initial tasks in the package. This is taking a little time to come up because it has to do some validation. Certainly taking a little longer than I expected, but it should be up any second now. Okay, here it starts now. The data viewer has opened. It invokes the Amazon Web Service, and in the data viewer, I can now see the results that were returned, and you'll see that it returned 10 rows for me. The title, all the titles include mountain bike, because that's what we requested. Returns the manufacturer, returns the review, which is, as I say, the kind of Amazon description of the item. And you can see that those are fairly complex descriptions, which will be important for us later on. And it also returns, I think, some other values, the URL at the very end of this. So it's invoked the web service and returned those values. And what I'm going to do now, in fact, is stop this process and go back to the design mode and just very quickly review what it is that we did here. We had a script component. We added a reference to the web service. We created a new instance of the web service. And because we were using it as a source, we invoked the web service in the create new output rows method. And then we took the results from the web service and wrote them into the output buffer columns. And it is those output buffer columns that are being passed down to the next components. So that's a very simple example, but I think a very effective example of how to use the script component right inside an integration services package. I've gone over it at some length, but it's actually much more straightforward to do. It really is very straightforward to get these components, to get web services integrated right inside your integration processes, and now you can use them with all the other functionality that integration services has available. So I hope that was an interesting demo for that. Return to the presentation and talk about some of the other things that we can do. And the very next step, after I got that data back from the web service with those long descriptions, well, I'm going to do some text mining on that. And I think the results that you got from that web service were actually pretty interesting in terms of explaining why text mining is becoming important. Because only about 20% of the world's data is actually in a structured format, is neatly structured in the form of databases and structured fields and discrete items. In fact, most of the world's data is simply lying there in documents. Think how much information about those goods were actually embedded inside that full text description that we had from Amazon. If I wanted to find out more information about those mountain bikes, what size their wheels were, what their target market was, things like that, even what colors they were available in, perhaps that's only available in that full text description, not called out as structured fields. So what can we do with integration services to help get into that unstructured data and find structure in there? Well, the first thing to say is that our incoming data, the data that we look at in our components, has to be either in the one of these data types, either GT wide string, which is of course the Unicode type, or alternatively as an end text column. Now you shouldn't worry too much about that, because even if your data isn't Unicode, you can still convert it to Unicode in the integration services flow. That's certainly quite possible. So the other thing that we have is that the algorithms for integration services will extract nouns and noun phrases. Those are the typical things that we're looking for. Currently, we only support English. In the future, we will support other languages, and it will be more extensible. But at the moment, this is very linguistically based, and it only supports English language. We have seen people trying to use it with other languages, not quite so successful. I mean, it's a very linguistic component. We need to be able, for example, to identify nouns, and nouns require a lot of linguistic knowledge to identify. You can set different delimiters, and you can set what we call the term length. In other words, if you're looking for a phrase, it might identify bike as a phrase, kind of four-letter phrase. Mountain bike, on the other hand, is a longer phrase. And if you only had kind of four-letter phrase, it would only pick up bike. It wouldn't pick up mountain bike as a phrase. So you want to set the term length appropriately. And then what the components do is they score the terms that it finds based on the frequency. Now, there's a very basic score which is called frequency, and that's just the number of times a term appears. And then there's a more complex frequency score called TF-IDF, which is really the total frequency of the term frequency as relates to the frequency in the entire document. In other words, how does the number of times you find it in this row compare to the total rows in the document? And that's a very useful measure when you're trying to understand the frequency of something in the entire data flow. Now we have two text mining components. The first is called the term extraction component. It will take incoming data, find the key terms, and then pass them to an output. So for example, it would take all those descriptions from the Amazon Web Service and find the key terms like mountain bike, wheel, saddle, whatever, and pass them aluminum frame, and would pass them to an output, which could be used to create a reference table from known documents. So for example, I want to find all the key terms that are important in understanding mountain bikes. I would pass those descriptions through, and now I would get a table of key terms. A good example of this might be if you were scanning something like resumes from job applicants. You might want to say, well, what key terms do I find in my successful job applicants? And take all the resumes of existing employees who are by their nature successful applicants and extract the reference terms from them. Now in the future, you would be able to compare incoming resumes with those reference terms. You can also use some of our other components, such as fuzzy grouping, to deduplicate items. So you might want to deduplicate bicycle and bicycles, or mountain bike and perhaps some misspelling of mountain bike that might be hidden in one of the documents. Now the companion component to term extraction is term lookup. Imagine I have searched through all my successful employees and found the terms that they use in their resumes. Now I would like to look at incoming employee resumes and say, well, how do they compare to the resumes of successful employees? And so I would use a term lookup. Given a reference table of terms, what terms can I find in new documents that match the reference table? Now, when you do this, one thing to be sure to do is to pass through a key column so that you can get back and identify the original document. But it's a very, very useful component for being able to say, okay, here's a reference table, such as my key customer names, or my key product names, or my key competitor names, or as I say, terms extracted from something like insurance documents or resumes. How does the incoming document compare to this one? It's a very, very useful component for doing that. So, having spoken about that, let's go and have a demonstration of it. And we're going to use the same example. We're going to use the Amazon Web Service example, and we're going to see what we can do with text mining in that web service example. So back to the Visual Studio environment and to integration services, and let's have a look at this package again. First thing I'm going to do, just for convenience, is remove a data viewer that I had added earlier. It's just a convenience step. I don't want that popping up in the middle of our next process. Now, if you remember when we looked at this package, there was in fact three components, three tasks involved. There was a prepare table task. All that does is just make sure the table exists and that it's cleaned up. It's kind of demoware task, if you like. The first task, however, has got nothing to do with the web service. The first task is there to make sure that we can find interesting terms in the AdventureWorks database. What do I mean by that? Well, imagine a scenario where I work in AdventureWorks and I have a catalog of my mountain bike products. And in this catalog, I have descriptions of the products. And those descriptions are actually largely free text descriptions. And I can show them here if I look in the query results preview. Now I have all these descriptions of my various items. What I'd like to know is which items on Amazon website are most similar to the items that I'm selling. In other words, which items on Amazon are competing with my items. How am I going to do that? Well, the first thing to do is to build a table which includes all the key terms from my own product descriptions. I do that using a term extraction component, and it's very, very easy to configure this. I simply take the description field, that field which had the free text descriptions, and it's going to give me a term column output and a score column output. There's a couple of things I want to look at. I want to look at the advanced tab here. I'm going to use the TF-IDF frequency measure, and I'm going to say that the minimum frequency is going to be 1, and the maximum length of the terms is going to be 30 characters. So I'm looking for nouns and noun phrases of 30 characters that appear at least once in my data flow, the maximum of 30 characters. I also have the opportunity, but I'm not using it, to use exclusion terms. Exclusion terms would be a table of terms that I didn't want to consider, things that weren't important to me, for example. Having done that, you'll see that what I get at the output here is a term and a score of that term, which I can now use to populate a table of terms. I can then filter out abbreviations, and what I'm doing here is simply saying, the items that come out that are interesting have to be more than 5 characters long. I'm not interested in anything that's short. And having done that, I load it into an interesting terms table in SQL Server. So let's see this in action. What I'm going to do here is show a little debugging technique where I can actually use 2 data viewers side by side. So I'm going to look at the description in one data viewer, and I do that by adding a data viewer and simply choosing the description field. And after the term extraction component has completed its work, I'm going to look at a data viewer which will show me the terms that were extracted and the score of those terms. Now, when I do that, when I look at term and score and add it as a data viewer, I will actually get 2 data viewers appearing side by side. Or at least I can arrange them side by side when they appear. So I'm going to execute this package, and we'll open it up in the Visual Debugger again. If you wait a moment for that to happen. We'll open it in the Visual Debugger and open 2 data visualizers. And when we open the data visualizers, what I'm going to do is drag them to dock them beside each other. See if I can just get this. This probably looks a little strange over live meeting, but let me just see if I can get these in place. And once they're actually in place, it'll be rather clearer what's going on. Once I've docked the visualizer in place, you'll see that these are the descriptions that I'm pulling out from my different products in my catalog. I can tell the data visualizer, or the process if you like now, to run on, and it will stop at the next data visualizer. See, at this point, I tell it to run on. It will run through text mining, and you'll see that it now extracts these terms such as performance. I can sort this by score as well if you like. You'll see great tread, heavy duty, sealed cartridge, elastic waistband. I presume that's for some sort of cycling shorts or something. Hollow axle, sealed pulley bearing. These are all terms which are important to in my product catalog. So I can detach this process and let it continue, and the entire package, in fact, will succeed at this point. Well, it doesn't load into SQL Server because I'm in debug mode, and I timed out there on my SQL Server destination. My SQL Server destination has a 30 or 60 second timeout, so it just times out when I'm talking through the debugging process. Okay, so what I'm going to do now is, having done that work and created a reference table of terms, now what I was doing with the web service may make a bit of sense, because what I was doing there was reading descriptions from the Amazon web service, and now I'm using another component, which is the term lookup component. And the term lookup component will look up to that table of interesting terms, and it will say, take the terms that I find in the product reviews and compare them to the terms that are in my reference table, and then those that match return to me the title and manufacturer and URL of that. Don't use a case-sensitive lookup, and let me know which terms were most interesting. So the level of interest is actually calculated, if you like, or the score is calculated by how many of the terms in the incoming records were found in the reference table. You can see the metadata of that here. Look up to the reference table and return that. Then I'm doing a very simple aggregation, and the aggregation will simply score those values and return them back to me. And it will group the bike model and group the manufacturer, and will count the number of terms that I've got, that I found that were matching. At the end of that, it builds a table of competitors, which I can then order or filter based on the level of interest of the various terms. So at this point, let's add a data viewer to the component here, and let's see what's actually going to happen. I'm going to say, look up the term and frequency, look up all these terms, and let's also add a component just before the term lookup. I'm going to go back to the other data flow task just for a moment to make sure that I don't have a data visualizer there. Now, the reason I'm doing this and removing the data visualizers from the other product, from the other data flow, is just to ensure that I don't have too many data visualizers appearing at one time. That would be, having 4 on screen at one time would be rather too many. But once I've actually removed those visualizers and returned to this component, to this data flow, I can execute the package. Again, we'll attach the visual debugger. We'll run through the initial 2 tasks, and we will populate with 2 data visualizers. And once again, we'll go to the Amazon web service and return those terms from the Amazon web service. So it connects to the Amazon web service, and will show me in a data visualizer the titles and so on, and the reviews of these components. We're going to text mine on those reviews and look up to the reference table that we populated from our own catalog. And based on that reference table, we're going to find out which features from the Amazon Web Service descriptions are actually found in our own catalog. And you'll see immediately that the Mongoose Scorch men's 26-inch dual suspension mountain bike has the term racing in common with our catalog, with a frequency of 3 terms. I can sort by frequency, for example, and see that the Schwinn S15 matches on comfort. The Schwinn Ridge AL Women's 26-inch matches on racing again, and so on. The mongoose scorch matches on terrain. And so I can actually score these and say, well, these are the items which are going to be competitive with the items in my catalog. Having then closed down the visualizers, I can let the process go on, and I will have populated a competitors table. And if I look at that competitors table, I'll be able to use that to build reports about my competitors, for example, and what products are most likely to be competitive. So I've used a web service, and I've used term extraction and term lookup to build a really interesting little business scenario where I can actually get into the free text data that would normally be difficult for me to use, and I can actually use this to build really compelling reports and business metrics about my scenarios here. Now, the last thing we were wanting to look at then was, having used text mining and web services, another advanced feature, which is the integration of data mining and integration services. Data mining models are built and deployed with analysis services. And you can get a lot more information about data mining and about the uses of data mining if you look at the analysis services samples and tutorials in books online. Really is a great feature and something that's very, very important for us. You can also use integration services to process and train the mining models. That's a kind of a control flow operation. Quite very often, you need to populate the mining model with more data, and you need to process it to find patterns that are in there. But very interestingly, you can also use integration services to query the mining model. And you can do that by having data mining integrated directly inside the integration services data flow process. At runtime, integration services can connect to the server, the analysis server, and use the data mining model that's there. So it's very important to remember that the mining model must exist on an analysis server and must be deployed to an analysis server. And integration services calls to that analysis server and uses the mining model that's there. Why would I use data mining as part of a data flow operation? Well, an interesting example might be to impute missing data. I might have unscanned items. I might have prices and so on, but not have the barcode for an item. And it would be possible to use data mining to say, well, based on, for instance, the weight of this item and the price of this item, I think it's probably this item in my reference set, and use the data mining model to predict that. I could also use data mining to identify bad data. So, for example, anomalous readings from equipment logs, readings which are outside the range of acceptable values, can be very difficult to write the rules to calculate that, because there may be so many parameters. But data mining can say, well, here's the good readings that we know about. Let's compare the incoming readings with the good readings and look for anomalies. And things like miskeyed age and price fields. So, for example, if I have some items which have been calculated, I had an example actually once from my own experience where somebody put an item in my shopping basket, and it was a tin of cat food that should have been 65 cents, and due to a miskeying it came out as $6.50. Within my shopping cart, I didn't actually notice that until I got home. I wasn't using data mining live on my handheld PC in the supermarket, but in fact I could have identified that. Perhaps using data mining would be an example of finding a miskeyed value. And you can also infer quite complex business rules, and that's what we'll be doing in our sample. In order to use the data mining query component, you need to have a server with a mining model deployed. And once you have that there, you can build a query using the data mining query language, and it's really fairly straightforward because there's a visual builder which allows you to take your incoming columns and say, well, in my mining model, which of these incoming columns are actually mapped to columns in my mining model? And then data mining is all about creating predictions. And so I can say, based on this incoming data, what can the data mining model predict? And so you select that value that's going to be predicted. I would also always suggest that you select some metrics from the prediction function, a prediction probability, for example, because it's all very well to have a mining model that predicts that this value is wrong, or this value is right, or this customer is going to be a gold card holder. but you want to know what the probability that that is actually correct. If you're going to be making business decisions based on predictions, I think you want to know some of the metrics behind that prediction. Pass through some columns that you want to use downstream. It's also very useful to remember to provide useful column names so that the users downstream actually understand what results they're getting. You'll see that again when we show the example. So if I was to look at an integration services data flow object, what you would see building up is that within my sources, I could, for example, take some disparate sources, merge them together, and perform a prediction based on that data. The prediction would be done by looking to analysis services, and when we look to analysis services, we look at the mining model in analysis services and pass it the data that we've sourced and merged, and then analysis services will close the loop back to us, calculate the probabilities based on the prediction model. And now I can do some interesting work there because based on the predictions, I can use integration services filtering features to filter out, say, good and bad data. One of the things I was saying was one of the useful scenarios is looking for something like outliers. Here, for example, is a clustering model of customers in my database, and I can see that there are large clusters of relatively low-income elderly people, relatively low-income young people, and relatively high-income middle-aged people. Now, what happens when I identify those clusters is I can now use my mining model, which knows about those clusters, to look at some incoming data. So, for example, I get 3 new values come in, and here's a middle-aged person who's not earning very much, a young person who's earning a great deal, according to the data. Maybe they're a rock star for all I know, and perhaps some elderly person who's earning a great deal as well, somebody who's made some really smart investment decisions perhaps in their lifetime. Do they fit the model? Well, they don't fit this model. I can identify them as outliers, and now I can do something important with them. I can filter them out and look at them and say, well, is this person a rock star? Or is it someone who's actually trying to overstate their income to get a mortgage? Or is it just a data problem? It's just an error in data. And I can use the rules to identify those people may be very complex, but data mining can infer it very, very easily. So let's go on to a very quick demo of data mining with integration services. I have a data mining package already built here, and let's just very quickly look at what is going to be done here. I have some data coming from Excel, and the data coming from Excel, in fact, I can show you it in Excel if you like. Data coming from Excel includes a list of customers, and those customers have some information about them. I have their marital status and their gender. I have their income. I know the number of children they have. I know where they live. The one thing I don't know is, do they own their own house? Now, in my business scenario, that would be very useful because I might want to target them for some advertising, for example, which was only suitable for house owners. But I don't have that information. However, I do have a data mining model. And the data mining model is called customer models, and it predicts homeowners, and it lives on my data mining server. So I can use the query, and this is the query which is built, but you don't need to write this. You can build it using the Visual Builder, which is a great deal more convenient. So invoke the Visual Builder. Look at the mining model here, and you can see that here's my incoming data. I have, for example, the commute distance and the marital status and the yearly income, the total children, and I can map these as appropriate, total children to total children, marital status to marital status, and commute distance to commute distance. And I can map it to the mining model itself. I can then choose certain values that I want to build. I built, for instance, the homeowner prediction and say, does the person own a house? I can simply drag this predictable value down to the builder, and that will give me a house owner flag column. Now remember that I wanted to also check the probability. So again, using data mining functions, I can select a prediction function called predict probability. And you can see that I've got lots of things here. I've got things like standard deviation, supportability, variance, and so on. But in this case, I'm predicting probability, and the prediction support value. and I can remove that or add new ones if I want. Having done that then, I will be using the data mining model to predict homeowners, and you can see that I've added a data visualizer here already. And the data visualizer is very straightforward. It's just going to show me the, let's take the first name, the last name, whether they're a house owner, whether we predict they're a house owner, and the probability that that prediction is correct. And that is me now predicting that as part of my data flow. Notice at the very end, I have a row count component dragged on from the toolbox. And the row count component is a very, very useful component. It simply takes a variable, in this case, a variable called variable, an integer variable, and it will simply count the number of rows passing into an integer variable. The great thing about it for this example is I can just use it as the end of a data flow, and I can debug the process without actually having to create temporary tables or files or whatever. So I'll execute this process, and you'll see what happens when we execute this. I'll attach a data visualizer again. We will source the data from Excel. The data will pass to the data mining query object, and the data mining query object will look to the analysis server. Now, when it looks to the analysis server, it will perform a prediction based on my incoming rows. And if you remember, it was predicting house owners and the probability that that house owner value is correct. So here we are. It said that Billy Ellison is not a house owner with a 56% or 55.8% probability, that Jay Lederman is a house owner with a 696 probability, that Paris Hyatt is not a house owner with this probability. And now I could use those probabilities later in the data flow to do some conditional processing based on them. So that is data mining in the data flow, processing a very complex business rule to predict whether someone is a house owner without me actually having to code all the details of that business rule. It's simply using an analysis services model to predict that. So with that, return to the live meeting, and let's just summarize what we've seen. Well, I think what you've seen is that advanced integration services enables you to do things which are way beyond traditional ETL processes. We've used web services and integration services. We've used text mining to handle the unstructured data, and we've also used data mining to infer business rules which are very complex and based on predictive models rather than hard-coded business rules. For more information, you can look at the TechNet website, which has white papers and webcasts and demos and all sorts of things to look at. And there's a great deal of technical information available on the MSDN Developer Center for Integration Services, including downloadable samples and sample components, for example, for writing your own code. For questions and answers, we'll be taking questions at the end. Use the question manager and submit questions using the Ask button, and I'll be very happy to answer any questions that I can at the end of this.
Excellent. Well, thanks, Donald. As Donald mentioned, if you have questions for him, go ahead and submit those now. We'll get to those in just a moment. I want to point out that we do record all of our webcasts, so if you'd like to see any of our previously recorded webcasts, as well as anything that's coming up, everything is posted at Microsoft.com/webcasts. And in addition, we'd love to hear from our audience, so if there's anything you'd like to see us do differently, or if you have any content ideas, you can contact us, and there's yet another URL posted there. And I'll just point out that you can print a PDF of the slides. Just go to that File menu in your upper navigation bar, so you'll get all these URLs. So today's webcast was presented using the Microsoft Office Live Meeting technology, and you can get a free 14-day trial. Just go to Microsoft.com/presentlive. And we have a survey coming up here. Like Donald mentioned, I just want to point out not only is your feedback valuable to us, but for filling out the survey, you'll automatically be entered into a drawing to win this 40-gigabyte Creative Zen Ultra MP3 Windows Media Player. So you should be seeing that survey now in your slide area, and just take a moment to fill it out before you log out. We really appreciate that. And Donald, I'm going to hand it back over to you and let you wrap up. Looks like we have a few questions coming into the queue.
Yeah, great. Thanks very much. There's some questions here, and let me try and just give you some quick answers to those. Mikhail has been asking, is VSA, part of Visual Studio 2005. In fact, VSA is an extension environment for Visual Studio, and it ships with any applications which use that. And in this case, it ships with SQL Server Integration Services. So you don't get it automatically as part of VS 2005, but it is available with integration services. Another question, an interesting one from Salam, which button should we hit to run only the script component? Well, the script component is part of a data flow, so you can't actually run the script component without running the rest of the data flow. In the example I was showing, I was running the script component at the very beginning of the data flow, so it was very easy for me to stop the process. But if a script component was consuming data from a source, it would need to run the source in order to get data to be used with it. So you can't really run the script component on its own. If you were building a script task, then that would be possible. You could right-click on task and select execute task, but not for the script component. Another question from Salam was, is it possible to have source code for the demo? And in fact, we'll be posting some source code about how to use web services on the MSDN website once the white paper is edited and published up there. A question from somebody with the initials BMG. What is the difference when a mining model is queried from the server as opposed to perhaps from a VS project? The difference is that, in fact, you can build the query when talking to a VS project, but at runtime, you can only invoke the model to actually perform a prediction on the server. So the project only provides metadata. The server actually provides the model that can do the prediction. So you need to have the mining model deployed in order to use that. Bill Walter asks if there's a lot of similarity between SSIS and BizTalk, because we can select data from many different sources and bring them into SQL. BizTalk is expensive and integration services is included in SQL Server 2005, so are there good reasons to spend the extra money for BizTalk? The answer to that is yes, absolutely. BizTalk and integration services are quite different applications. They have some similar concepts in that indeed they do bring data together and they do some processing on it, and you can use them to load data into SQL Server. But integration services is primarily concerned with data integration, how you take data at the data layer, the storage layer of your applications, and integrate that together to build, for example, data warehouses. What integration services is not intended for is doing things like real-time processing, where I have an order coming in from a web service and I need to fulfill that order and do some complex processing on that and push it back out in real time. And I'm only dealing with one order at a time, and those orders will be continuously flowing. Integration services is a batch-oriented data integration application. BizTalk is about integrating applications in real time at the logical and the business logic layer, and that's not integration services speciality. The complexity of trying to build something which is robust and reliable at the logical layer, at the business application layer, is where the extra value of BizTalk comes in, because you don't want to lose orders because your application has crashed. You need to be able to process those orders, have them fail over, and have them 100% reliable in real time while taking care of all the business logic across complex applications like SQL or SAP. And that's the distinction really between integration services and BizTalk. I have a question from Bikramjit, who asks that he's interested in dynamic creation of packages during runtime, and are we planning on giving such a presentation? I think I'll take that as a request, and I'll see if I can work with Janet to plan such a presentation. We didn't have one in the current series, but I'll take that as a request, and we'll work on one for the future. So thank you for that.
And I think we got all the questions, right?
I think so. Thank you very much.
Excellent. So I'll just remind everybody, please do take a moment to fill out that survey before you log out. And I'll remind you also that you can watch your inbox tomorrow for an email with information about viewing this webcast on demand and downloading a Windows Media file. So that email should also include a link to the downloadable PowerPoint of today's webcast, but if you'd like to get that right now, you can also go to the File menu in your upper navigation bar and do a print to PDF. So with that, I'd just like to extend a special thanks to Donald for today's presentation. So that concludes this TechNet Live meeting. I'd like to thank our audience for joining us, and our audience may now disconnect from the audio portion of this event.